Non-polynomials. Define a polynomial in one variable. State the general form of a polynomial in one variable. Determine the degree of a polynomial in one variable. And determine the zero of a linear polynomial. Look at the expressions on the screen. Can you identify the polynomials in this set of expressions? A polynomial is an expression containing one or more terms where coefficients are not equal to zero and exponents of variables are whole numbers. A polynomial can have one or more variables. Let's review again the expressions that we saw earlier. As you can see, the expressions are categorized as polynomials and non-polynomials. So, what's the main difference that you can see between expressions in the two categories? The terms of the polynomials have whole numbers as exponents, while the terms of non-polynomials have fractions or negative numbers as exponents. If you examine the list of polynomials further, you will see that some of them have a single variable x, while others have two variables, x as well as y. A polynomial that contains one variable is known as a polynomial in one variable. A polynomial in one variable can be represented as p of x, q of x, or f of x, and so on, where x is the variable. For example, p of x is equal to x squared plus 2x plus 1. The general form of a polynomial in one variable is p of x is equal to anx to the power of n plus an minus 1x to the power of n minus 1 plus and so on till a0, where an minus 1, and so on till a0 are real numbers. The exponents of terms are whole numbers. N, the highest exponent, n, is the degree of the polynomial, where an is not equal to 0. You can name a polynomial on the basis of its degree. The polynomial of degree 1 is called the first degree or linear polynomial. The general...
Hi, I'm Nabamita.
And I'm Abhishek.
We are your master teachers at Vedantu.
We are proud to announce yet another amazing edition of Vedantu's scholarship.
Is ax plus b, where a is not equal to 0. The maximum number of terms is 2. For example, x plus 1 is a linear polynomial. The polynomial of degree 2 is called a second degree or quadratic polynomial. Its general form is ax squared plus bx plus c, where a is not equal to 0. It has a maximum of 3 terms. For example, x squared plus 2x plus 1 is a quadratic polynomial. A polynomial of degree 3 is called a third degree or cubic polynomial and is represented as ax cubed plus bx squared plus cx plus d, where a is not equal to 0. Such a polynomial can have a maximum of 4 terms. For example, x cubed plus 3x squared plus 3x plus 1 is a cubic polynomial. Similarly, any polynomial of a degree greater than 3 is named on the basis of its degree, such as 4th degree polynomial, 5th degree polynomial, and so on. In a polynomial with one variable, the value of the variable where the value of the polynomial becomes 0 is the 0 of a polynomial. In other words, the value of x for which the value of the polynomial equals 0 is the 0 of the polynomial p of x. Let's take up a problem as an example. Find the values of a linear polynomial p of x is equal to 2x minus 4 at x is equal to 1, minus 1, and 2. Let's solve the polynomial for each of these values of x. First, substitute x with 1 in the polynomial. The value of the polynomial is minus 2.
My boss is going to kill me. I'm late for the 5th time this month. Mickey, मेरा चार्जर देखा है?
Similarly, the value of the polynomial for x is equal to -1 and x is equal to 2 is -6 and 0 respectively. Value of the polynomial is 0 when x is equal to 2. Therefore, 2 is the 0 of the polynomial. P of x is equal to 2x minus 4. In general terms, if P of x is a polynomial and k is a real number, and if P of k is equal to 0, then k is called the 0 of the polynomial. You can determine the 0 of a polynomial through two methods, by trial and error and by equating polynomial to 0. Consider a linear polynomial. P of x is equal to 2x plus 4. Let's first use the trial and error method to find the 0 of this polynomial. To begin with, let x is equal to 1. Substituting 1 in the polynomial, you get 6, which is not equal to 0. If x is equal to -1, then the value of the polynomial is 2, which is also not equal to 0. Try using another value, 2, as the value of x. The value of the polynomial is 8, which is again not equal to 0. In the fourth try, you use -2 as the value of x. You will find that the value of the polynomial is 0. Thus, using the trial and error method, you can determine that the 0 of the given polynomial is -2. As you can see, the trial and error method can often be long and tedious. An easier way to determine the 0 of a polynomial by using the other method, that is, equating the polynomial to 0. In this method, you can find the 0 of the polynomial P of x is equal to 2x plus 4 by taking x as the subject. Thus, P of x is equal to 2x plus 4. P of x is equal to 0. Thus, the value of the polynomial 2x plus 4 is equal to 0. On solving, you get x is equal to -2. This indicates that the value of P of x is equal to 0 if x is equal to -2. Therefore, -2 is the 0 of polynomial P of x. Thus, you can obtain 0 of a polynomial by equating it to 0. Here is a simple problem that involves division. John has 7 apples. He shares the apples with his friends, JC and Jill, so that all 3 of them get an equal number of apples. How many apples remain with John? To find the remaining number of apples, you need to divide the number of apples by the number of people. You can do this through the division rule. Each one of them gets 2 apples, which means 6 apples are distributed. Therefore, the remaining number of apples, or the remainder, equals 7 minus 3 times 2, which is equal to 1. As you can see, it is easy to perform these operations with integers. However, if the number of apples and recipients were polynomials, such as 8x squared minus 3x plus 5 and x minus 2, then the remainder can be calculated quickly and easily by using a theorem called the remainder theorem. Welcome to the lesson on remainder theorem. At the end of this lesson, you will be able to state the remainder theorem, verify the remainder theorem, and apply the remainder theorem. The remainder theorem states that if P of x is a polynomial in x and P of x is divided by x minus a, then the remainder is P of a. Let's now see how we can verify this theorem. It is given that the dividend is equal to P of x and the divisor is equal to x minus a. Let the quotient be q of x and the remainder be r. On the basis of the division rule, you can derive the equation P of x is equal to x minus a times q of x plus r. This equation is true for all real values. Therefore, if we assume x is equal to a, then P of a is equal to a minus a times q of a plus r. On solving, you get r is equal to P of a. Let's now apply the theorem to solve our problem. In the problem given at the beginning of this lesson, the dividend is equal to 8x squared minus 3x plus 5, and the divisor is equal to x minus 2. Let P of x is equal to 8x squared minus 3x plus 5. Now according to this divided by x minus a, then the remainder is P of a. Therefore, in this problem, the remainder r is P of 2. If you replace x with 2 in the polynomial P of x, you get the remainder r is equal to 31. Remainder theorem states that if P of x is a polynomial in x and P of x is divided by x minus a, then the remainder is P of a. The remainder theorem specifies the remainder in cases where the divisor is x minus a. However, there may be cases where the divisor does not appear in the form x minus a. In such situations, you can use the following guidelines to determine the remainder in the division of a polynomial. If a polynomial P of x is divided by x plus a, then the remainder is P of minus a. If a polynomial P of x is divided by ax minus b, then the remainder is P of b divided by a. If a polynomial P of x is divided by ax plus b, then the remainder is P of minus b divided by a. That is, apply these guidelines to solve some problems. In the first problem, you need to find the remainder when a polynomial minus 8x cubed plus 4x squared minus 2x plus 7 is divided by another polynomial x plus 1. Here, the divisor is x plus 1. According to the guidelines provided, if P of x is a polynomial in x and P of x is divided as P of minus a, the remainder is P of minus 1. If you replace x with minus 1 in the polynomial P of x, you get the remainder is equal to 21. In the next problem, you need to find the remainder when a linear polynomial 2x minus 1 divides another polynomial minus 8x cubed plus 4x squared minus 2x plus 7. As given in the problem, the dividend is equal to minus 8x cubed plus 4x squared minus 2x plus 7, and the divisor is equal to 2x minus 1. According to the guidelines provided, if P of x is a polynomial in x and P of x is divided by ax minus b, then the remainder is P of b divided by a. Therefore, in this problem, the remainder is P of 1 divided by 2. If you replace x with 1 divided by 2, in the polynomial P of x, you get the remainder is equal to 6.